Right, so hello everyone. My name is Dmitry Zhikharevich, never mind my screen name. I'm a postdoctoral researcher at the STS Center, European University in St. Petersburg. And I'm very happy to welcome you to our very first seminar in a new series, which is tentatively called Social Studies of Climate Change. And it's my great pleasure to introduce our today's speaker, Stefan Schaefer, who is a research group leader at the Institute of Advanced Sustainability Studies in Potsdam, Germany. Stefan also maintains fellowships at Harvard University's program on Science, Technology, and Society, where he's a close collaborator of Sheila Jasanov's and her team. And he also maintains a fellowship at the University of Oxford's Institute for Science, Innovation and Society. Stefan was trained in political science, history and philosophy at universities of Tübingen and Cornell. And he holds a PhD in international relations from the Free University of Berlin. So his research draws on STS and is developing new questions about how democratic politics, sustainability, science and global governance intersect. Today, Stefan is going to talk about his more recent research project on the history of climate geoengineering and also about Earth system science and its Cold War genealogy. I would also add that I'm hoping that we also hear from Stefan about how to sustain collaborations between social and natural science communities, and also how to make the kind of research some of the people here do, the STS broadly conceived, more open to the public. So you can post your questions in the chat. If you feel you're not able to phrase it in English, you can send me a private message and I'll translate it and then ask Stefan to answer. Okay, so without further ado, I'm stopping here, and Stefan, the floor is yours. Thank you.
Well, thank you so much, Dimitri. I really appreciate the opportunity to speak here in this forum, and I was very happy to find your invitation in my inbox a while back after you and I spent time together at Harvard's STS program, because what you didn't mention is that that is where we met, because you were a fellow there as well. So thank you very much for inviting me. I'm excited about this talk. Well, for one, because I'm excited to speak to this audience, and for the other, because I'm presenting at least partly some new work for the first time, and that work touches upon themes and historical events that perhaps members of this audience today may be familiar with. So I look forward very much to also having time at the end for a bit of discussion and Q&A around these topics and themes. And of course, it's always a bit of a temptation, when there's such a nice invitation with so much time to present one's work. It's a temptation for academics to use that time and talk, but I'll really try and leave some good time at the end for us to discuss. So with that, I'll move into a short overview of what I'd like to present to you today. I'll give a short, maybe a conceptual introduction and a bit of background to the work that I do, the perspective that I take, and which I've developed, as Dimitri mentioned in his kind introduction, in close collaboration with Sheila Jasanov. I'll then give an overview of climate geoengineering in historical perspective. I think there's a lot of things to unearth there that are not always familiar to all listeners, even if they've encountered the topic before. To then segue into this bit of work that is also new for me and that I'm presenting for the first time here on our Earth system science, its Cold War genealogy, and global climate politics following from that genealogy. And I'll end with some very short concluding thoughts that'll hopefully get us into an open conversation, I'd say, more than perhaps a Q&A. and indeed perhaps around some of the topics that Dimitri mentioned are of interest to him and you, around interdisciplinary collaborations between social scientists and natural scientists, and also reaching out to a broader public from within this kind of work. So I'll start with a short introduction and background, and indeed I'll start by quoting Sheila Jasanoff, because the work that I do builds on what we might call the co-productionist branch of Science and Technology Studies, or STS, which integrates and complements insights and methods from diverse fields. So it's itself an interdiscipline, we might say, including sociology, cultural anthropology, political theory, history, philosophy, international relations. And this, what I give you here, is perhaps the most widely cited definition of co-production. So it reads, co-production is shorthand for the proposition that the ways in which we know and represent the world, both nature and society, are inseparable from the ways in which we choose to live in it. Knowledge and its material embodiments are at once products of social work and constitutive of forms of social life. Society cannot function without knowledge any more than knowledge can exist without appropriate social supports. Scientific knowledge, in particular, is not a transcendent mirror of reality. It both embeds and is embedded in social practices, identities, norms, conventions, discourses, instruments, and institutions. In short, in all the building blocks of what we term the social. And so this definition, what stands out to me is how it encapsulates a symmetry between the epistemic and the normative, or between knowledge and power, between science and politics, expanding on previous articulations of what we might call the symmetry principle in STS. For those of you who are familiar with STS, you will be familiar with its founding figures, such as David Bloor and his colleagues in the STRONG program of the sociology of scientific knowledge. So they advocated for symmetry between explanations for true and false beliefs, that one should not explain false beliefs different from how one explains true beliefs. Or the symmetry principle as it was formulated by Bruno Latour and his colleagues, such as Michel Calon or John Law, who in their actor network theory advocate for symmetry between what we have come to call nature and what we have come to call culture, with the famous consequence, of course, that in this actor network perspective, humans are not the only ones who are granted agency. Non-humans can, in this perspective, be actors too, or actants, as actor network theorists would have it. So what does this particular form of symmetry that we find in the concept of co-production between the epistemic and the normative, between knowledge and power, what does it mean to treat symmetrically these things, knowledge and power, the epistemic and the normative, science and politics? So at the conceptual level during this talk, that's what I hope to have demonstrated to you by the end, is one possible approach to this question. And in giving just one more short conceptual note before I move on to the substance of the talk, I've been, over the course of this work, been influenced perhaps by the work of Paul Edwards, which I'd like to mention. On the one hand, because of its empirical richness, and on the other hand, because of its conceptual propositions. And one of that conceptual propositions is the idea of infrastructural globalism. So in this article on the right-hand side, which also found its way into parts of his later book, The Vast Machine, Computer Models, Climate Data, and the Politics of Global Warming, in that article, Paul Edwards develops the idea of infrastructural globalism using the example of the World Meteorological Organization. And using that example, he traces what as a profoundly important, I'm quoting now from the text, a profoundly important transition from voluntarist internationalism based on shared interests to quasi-obligatory globalism based on a more permanent shared infrastructure. So he's saying basically that in a kind of historical dynamic, a historical development, from these shared interests in building a kind of collective infrastructure that helps support knowledge about the global level, in this case, meteorology, emerged this more permanent shared infrastructure that then no longer made it possible to operate outside of that infrastructure. And my goal, especially in the second half of my talk today, will be to ask about possibilities for inflecting this idea of infrastructural globalism with a co-productionist sensibility for the intimate relationship between knowledge and power. So to ask questions like, who built this shared infrastructure? Who created the permanency that we today inhabit and that is now for us quasi-obligatory? And what does this infrastructure perhaps also move out of the dominant frame that we have for knowing, representing, and...
Бля, вы видели, чем мне в чат пишет?
Okay, I'm sorry, Stefan. I gotta stop this.
Okay.
Just a sec, because we have some people who are trying to sabotage it.
Let's see.
Give me a second. I'm sorry. I'm just gonna ban a few people who seem to disturb the talk. Yeah. Okay, I think we can continue. Sorry about that.
Okay, no worries. These things happen in this new Zoom era that we all inhabit, and that also seems to be quasi-obligatory.
Right.
I would have loved to come visit you in St. Petersburg, of course, but unfortunately, in the current situation, that is not yet quite possible.
Well, at some point, definitely. Okay.
That will be wonderful. So this was actually, I mean, this is basically concluding the kind of conceptual introductory remarks that I wanted to make. So a point about co-production and then followed by a point about infrastructural globalism and how that concept of infrastructural globalism might be inflected with a sensibility for the co-productionist attention to the intimacy between knowledge and power. So moving on to the second part of the talk, I'll be speaking about climate geoengineering in historical perspective. And today in the discussions of climate geoengineering, this is often one of the starting points for these conversations. So this will be a familiar image to many of you. It shows leaders of France and the United Nations celebrating the adoption of the Paris Agreement in 2015. And in many ways, the Paris Agreement has become an important frame of reference for discussions of climate geoengineering today, because one of the things that states agreed on in the Paris Agreement is that global average temperature rise should be limited to well below 2 degrees Celsius, and that efforts should be pursued to limit it to 1.5 degrees Celsius, as stated in Article 2 of the agreement that I'm showing you here. Article 4 of the agreement then goes on to specify this. And it says, in order to achieve the long-term temperature goals set out in Article 2 that we just had, parties aim to reach global peaking of greenhouse gas emissions as soon as possible, recognizing that peaking will take longer for developing country parties, and to undertake rapid reductions thereafter in accordance with best available science. And now comes an important part that I've underlined for you in the slide, so as to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of this century, on the basis of equity and in the context of sustainable development and efforts to eradicate poverty. So what does this mean, to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases? Well, if we look at the warming projections for 2100, for the year 2100, as they're given to us by the Climate Action Tracker, we can see that the current policies in place, so we have the historical emissions in black, and then we have the top kind of blue possibility space of current policies leading to something between 2.7 to 3.1 degrees of warming. We see that if the pledges and targets are followed below that, so the kind of line that goes beyond this larger possibility space and leads to 2.4 degrees Celsius of warming, if the pledges and targets that have been submitted to the UNFCCC under the parties to the Paris Agreement, but that haven't yet been translated into actual policies, if those are implemented, we would arrive at this level of 2.4 degrees Celsius. And then there's a new path that they've just added at the Climate Action Tracker called optimistic net zero targets. And they're called optimistic because they've been announced, but they haven't yet been submitted to the UNFCCC. So a bunch of countries and entities, I think 131 in total, have, at least as counted by the Climate Action Tracker, have submitted so-called net zero targets, which means that at some point they want to arrive at a point where they no longer emit more than is on the other side of the equation, somehow removed out of the atmosphere. That's what net zero means in this context. And you can see that if you follow the lines to the 2 degrees Celsius consistent path and the 1.5 degrees Celsius consistent path even more so, you at some point are crossing the zero line of greenhouse gas emissions, right? So we'll have the black line that marks the zero emissions line. And at some point, especially for the 1.5 degrees Celsius consistent path, you cross below that line into what we might call negative territory. And so that would mean, that implies that at that point in time, you are removing more, the world is removing more CO2 from the atmosphere than is being emitted into the atmosphere. And this is also visible in other graphs. This is a bit older, from 2014, but it says it a bit more explicitly, which is why I like this graph. For one, I like it because it kind of shows all these different pathways. I think each of these kind of lighter colored lines is one scenario, and then the kind of big lines connected by these dots are the so-called representative concentration pathways that the Intergovernmental Panel on Climate Change, the IPCC, used in its 5th assessment report to kind of build scenarios for how to achieve certain temperature levels by end of this century. And what you see here is that for the scenario, the representative concentration pathway that leads to a global warming in the year 2100 of 0.9 to 2.3 degrees Celsius, you move below the zero line somewhere around 2070. But you have this hint in the kind of gray shaded area below the zero line that what you're looking at here are net negative global emissions. So that means you're removing more from the atmosphere than you're putting into it. And to remove more from the atmosphere than you're putting into it, of course, means that you have to have just negative global emissions. So some kind of removal from the atmosphere of CO2 much, much earlier than 2070. Right, and the more ambitious pathways here also cross the zero line much earlier than 2070 themselves, so it would have to be even before that, which means that essentially to arrive at that point, to make that perhaps somewhat plausible future possibility, there has to be a massive buildup of infrastructure for removing CO2 from the atmosphere, basically starting now. And here's another graph that kind of shows the implications of reducing emissions. Well, let's say that the implications of reducing emissions only very, very fast, as opposed to reducing emissions very, 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 very fast, right? Because as you can see, I mean, the declining line here is very steep in any case, but the less steep it declines, the more you have to go into what we might call negative territory, the more you'll have to be removing CO2 emissions from the atmosphere later on in the century, right? So it's a bit like, perhaps like taking out a loan or so from a bank, right? As if there were a global carbon bank or so, where you say, well, we want to keep emitting a bit more today, and we promise that therefore in the future we're going to be removing more from the atmosphere. We're going to try real hard. Of course, one of the open questions is, why should the world try so much harder later if it's going to try less hard in the present? And this is what's sometimes referred to as the moral hazard concern, that even discussing the possibility of these hypothetical future technologies might reduce pressure on reducing emissions in the present. So Mark Lawrence, who's the scientific director at the IASS that I work with, and we put it this way in a contribution in Science in 2019. We said that these hypothetical technologies shape climate scenarios, right? So that climate scenarios of future developments are strongly shaped by assumptions about how much carbon dioxide can and will be removed from the atmosphere in the future. And we kind of give a list of possible technologies or approaches, options that have been suggested for how this might be achieved on the right-hand side here. I'm not going to go through all of them, but large-scale afforestation, of course, is one that everyone has heard of, and that's kind of been a prominent proposal for a longer time now. Another one that's very prominent, especially in these modeling calculations and integrated assessment models, is bioenergy with carbon capture and storage, where the idea is that you would generate energy from biomass, and during the burning process, you capture the CO2 that gets set free from the burning, and then you store it underground permanently. And that's very prominent in models, because it's a way in which a model can kind of have two things at once. It can have both energy and less CO2 in the atmosphere. So if those are things that the model optimizes for, it'll want to have as much of that as it can. Now, one thing you might have noticed is that in all this discussion so far, I haven't mentioned really the term geoengineering, or climate geoengineering, as we now refer to it. And that's because there has been indeed a decoupling over the last couple of years since the Paris Agreement. So climate geoengineering used to be, and in some instances, some places still is, used to be subdivided into two categories: carbon dioxide removal, or CDR, what I've been talking about so far, on the one hand, and then solar radiation management, which I'll get to in a moment, or SRM for short, on the other hand. But as CDR, carbon dioxide removal, or negative emissions, actually, as it's also, or perhaps even mostly, referred to by now today, as these approaches have moved into the mainstream, or as we might say in more of an STS-inflected manner, as they have become normalized, they've kind of shed that historical association with the term geoengineering, presumably also because geoengineering has become a term that is controversial when it's used, and for something to become accepted in the kind of mainstream portfolio of approaches, that controversiality was a barrier. So, but on the other hand, looking back historically, now getting to the more historical part of my talk, the term geoengineering was originally first introduced actually to refer specifically to the removal of CO2 from the atmosphere. So this is from a publication as early as 1977 by Cesare Marchetti, then at the International Institute for Applied Systems Analysis, IASA, in Luxembourg in Austria, called On Geoengineering and the CO2 Problem. And what Cesare Marchetti proposed here is that CO2 might be removed from the atmosphere in what he calls a kind of fuel cycle for fossil fuels, where CO2 is partially or totally collected at certain transformation points, quoting now from this abstract. And then he suggests disposing of it by injection into suitable sinking thermohaline currents that carry and spread it into the deep ocean that has a very large equilibrium capacity. So kind of removing CO2 from the atmosphere, injecting it into the ocean at suitable injection points, and then having it from there spread into the deep ocean, where the plan is that it will stay for a long time. And he suggests that the Mediterranean undercurrent entering the Atlantic at Gibraltar has been identified as one such current. It would have sufficient capacity to deal with all CO2 produced in Europe, even in the year 2100. So this is kind of the first mention of the term geoengineering in the literature, at least that I'm aware of. And I want to stick to this theme of kind of the oceans and of removing CO2 from the atmosphere via the oceans. So the oceans kind of becoming this space in which mitigation can occur. And one might even say a technology for mitigation. Because it's also one of the kind of older proposals for how removing CO2 from the atmosphere might be achieved, and it's making a bit of a comeback right now. So there was this short note, a very short kind of comment by John Gribben in Nature in 1988, where he says that a possible way to alleviate the anthropogenic greenhouse effect, which is at present a cause for concern, might be to add iron compounds to the oceans as, quote unquote technological fix to remove carbon dioxide from the air, right? So, and the suggestion is that if you fertilize certain areas of the ocean that lack certain nutrients, then in those areas phytoplankton will grow, and phytoplankton in its kind of growth phase will take up CO2 from the atmosphere, and then as it dies off and settles down on the ocean floor, will take the CO2 that it's taken up from the atmosphere with it, and that CO2 will then remain stored at the ocean bottom. And a few months after this short note by John Gribben came out in Nature, oceanographer John Martin reportedly commented at a workshop, "Give me half a tanker of iron and I'll give you the next ice age." So it kind of built a certain degree of hype around this idea, sparking several field experiments. So since the 1990s, there have actually been quite a few field experiments of ocean fertilization. Some of them also drawing considerable controversy. There was one experiment led by German and Indian scientists called LOHAFEX, which became controversial, at least in Germany, kind of up to the level of where it entered ministerial kind of high-level politics around whether it should be allowed to proceed or not. Notably when the vessel, the research vessel, was already traveling to the research location. So these scientists were on board of their research ship and were wondering whether they would be allowed or not to go ahead with this experiment. In the end, then the okay was given after kind of 4 studies had been commissioned about the legality of the experiment, and the ship had been kind of cruising back and forth for I think 2 weeks or so. And this all led to actually now ocean-based activities being quite strictly regulated under the law of the sea, and particularly the London Convention and the London Protocol, which now regulates what it calls marine geoengineering, defined as, quote, a deliberate intervention in the marine environment to manipulate natural processes, including to counteract anthropogenic climate change and or its impacts, and that has the potential to result in deleterious effects, especially where those effects may be widespread, long-lasting, or severe. So marine geoengineering now has kind of caught the attention of first scientists in the 1990s, then regulators in the 2000s perhaps. And now there's been this kind of resurgence of interests with several projects on marine geoengineering, as we may have called it in the past. Now it's mostly referred to as kind of marine-based carbon dioxide removal, or ocean negative emission technologies, as we call it in this project that my group at IASS is participating in. We just got a new postdoc on board who's working on this. So this is the Ocean Nets project. You can visit the website at oceannets.eu. And so my group is involved in this project, which is funded by Horizon 2020, by the EU's Horizon 2020 program, where together with the University of Hamburg, we're responsible for a work package on governance, policy, and international law. But so to return to kind of the main story of climate geoengineering, how this story is today generally told is that even when efforts to reduce emissions are combined with these efforts, potential future hypothetical efforts to remove emissions from the atmosphere, this might still not be enough to limit temperature change, temperature rise to the limits set out in the Paris Agreement. And so the story goes that some people are now considering more radical interventions, such as what I've mentioned before, reflecting incoming sunlight away from Earth and back into space, or what's been called solar radiation management, SRM for short. And so this is kind of the other, historically, the second other category of what we call climate geoengineering. But it's, I think, increasingly coming to be seen as kind of the geoengineering approach, so that when people speak of geoengineering, or some also specify it by saying solar geoengineering, this kind of reflecting sunlight approach is usually what they mean. And just to give you an idea of very recent developments around this in the US, I think it was last month maybe or so, this report came out, reflecting sunlight recommendations for solar geoengineering research and research governance, issued by the National Academy of Sciences, Engineering, and Medicine in the US. And they call upon the United States to establish a national solar geoengineering research program. And they say that a reasonable initial investment for this program is within a range of $100 to $200 million total over 5 years. So there's some momentum developing here, I'd say, kind of this very open call for a relatively large scale research program. Small scale, some might say, compared to other research activities, but $100 to $200 million over 5 years is still, you can do quite a few things with that. So this is a recent development that I thought I'd mention. And the technologies that they're looking at in the report are these 3 approaches to reflecting sunlight. The top one in this picture is the idea to increase the scattering of incoming sunlight by introducing stratospheric aerosols into the stratosphere at a certain height, 16 to 25 kilometers, it says. Then one approach that consists of thinning out very high cirrus clouds to allow this kind of like an inversion in a sense. It's not to block incoming sunlight, but it's to allow more heat to escape, more kind of infrared radiation that leaves the Earth as heat, to allow more of that to escape back into space, because cirrus clouds supposedly function to kind of keep that outgoing warmth back in. And at the very bottom, at the lowest level, to increase the reflection of marine clouds by making them brighter and more long-lived. So injecting particles into clouds that would make them brighter and would make them last longer to reflect more incoming sunlight. And to kind of stick to the recent developments in this field, there has for a while been discussions going on around the possibility of conducting field experiments on solar geoengineering. And this is a picture that shows a proposal, or an experimental setup, I should say, coming out of Harvard University. So a group of scientists at Harvard University have long been planning an experiment to test some aspects of solar radiation management via the injection of reflective particles into the stratosphere. And these plans have kind of been changing and going back and forth. They first wanted to, I think, have their test flight be launched from, I believe, Texas or Arizona. And the most recent change kind of has been to plan instead a launch from Sweden. And in then very recent developments, this planned launch, which was, I believe, set to go, was in fact canceled following kind of opposition from local groups against the experiment, who opposed it for various reasons. But one reason that kind of figured prominently in the arguments that these groups put forward for why the experiment should not proceed was that it is in many ways kind of setting an example as the first of its kind, that it's kind of, might lead us down a slippery slope, is a term that's often used in this context, where it's no longer as easily possible to turn around, even when kind of information becomes available that makes turning around seem advisable, because vested interests have developed, because kind of there are these precedents that make things in the future easier than they are now, supposedly in the absence of field experimentation on solar geoengineering. But as some of you might know, this experiment would not actually be the first experiment on solar geoengineering to be conducted, because in fact, a group of Russian scientists had in 2009 already conducted an outdoors experiment on reflecting sunlight away from Earth via an artificial aerosol layer. So what you see here is on the left-hand side, it's the kind of cover of the paper that the group published, led by Yuli Israel, who I'll get back to several times during this talk. And then the pictures show the kind of the experimental setup where they introduced an aerosol layer from a car, from the back of a truck, and from a helicopter, and then measured kind of how that changed incoming sunlight over the area where that aerosol layer had been dispersed. And but this is, while it may have been possibly the first experiment, it's still not the only experiment that has been conducted on solar geoengineering, because there is also an experiment that was led by an American group called the Eastern Pacific Emitted Aerosol Cloud Experiment in 2011. So this is an outdoors field experiment that's been conducted off the coast of California. And it's actually, it speaks to this, what I mentioned before on the slide with the three approaches to reflecting sunlight. It speaks to the bottomest of those approaches on increasing the amount of sunlight that gets reflected by clouds. So what they did is they introduced particles into clouds over the ocean and then measured how that changed the reflectivity of those clouds. And one thing I'd like to draw your attention to from that paper specifically is this passage that I've underlined here on the bottom right. It's a box that they have in the paper on cooling efficiency of cargo ships and smoke. And what the paragraph that I've underlined here suggests, or maybe I'll just read it out, although this is a very simplified calculation, we find that if half of the open ocean transit days of a cargo ship result in tracks that are on average 15% brighter than the surrounding clouds and cover 2,500 square kilometers, then cargo ship transit, for consumers only, could be considered carbon neutral in the sense of having no net warming effect transportation. Further, we find that smoke generators on board smaller ships that require less than 2% of the fuel per transit mile could provide a net cooling effect, which could be used to offset some of the warming caused by ship CO2 emissions. So what the paragraph suggests is that ship tracks from cargo ships under certain conditions lead to an increase in the reflection of sunlight away from Earth, such that these ships could be considered carbon neutral transportation in the sense that they have no net warming effect. And that if smoke generators were installed on smaller ships, and this, it goes quite far, right? This could even provide a net cooling effect, which they say, quote, could be used to offset some of the warming caused by ship CO2 emissions. So that if ships kind of introduce additional amounts of smoke into clouds, they could brighten those clouds and thereby offset some of the warming that they cause from emitting CO2. And this has been taken up recently in interesting ways in an initiative by the International Organization for Standardization, or at the International Organization for Standardization, driven mostly by a US based company that wants to kind of introduce exactly that possibility into carbon accounting, right? So the initiative is called Greenhouse Gas Management, Guidance for the Quantification and Reporting of Radiative Forcing Based Climate Footprints and Mitigation Efforts, right? So the idea is that the impact on climate of certain activities can be measured via the radiative forcing of those activities. And radiative forcing is a concept from climate science that kind of means the change in energy balance that is caused by these activities. And so the idea is that radiative forcing, this change is not brought about only by kind of heat trapping greenhouse gas emissions that are emitted from these activities, but that if kind of cooling or reflecting particles are emitted into the atmosphere from these activities, then that would also have a radiative forcing effect, but in the other direction, right? So not only a warming effect, but also a cooling effect from emitting these kind of reflective particles, for example, or other cooling effects. So the examples they give include the brightening of urban areas, for example, by installing white roofs, land use changes that can have either positive or negative radiative forcing changes, and then here we get back to the clouds over the ocean, restoring ocean albedo when considering reflectivity from the top of the atmosphere, e.g. cloud restoration. So they speak specifically to the possibility that restoring clouds could be used in the calculation of climate footprints to make them less bad, so to say, right? So an activity that before was evaluated based only on the emission of greenhouse gases that it produces and the warming that it produces, could in the future also be evaluated based on kind of the cooling that it produces, right? So it creates an entire new regime of of climate accounting, if you like, right? Where these different effects can kind of be balanced against each other. And it's an initiative that's been controversial. It's been reported on controversially. This draft has actually leaked from the negotiations. It's not supposed to have gone public. So I'm not sure what the status is of this at the moment, but it really kind of represents would represent, if this came to be the kind of the mentality, one might say that the governed mentality to climate politics, it would present quite a sea change in how we think about kind of activities in the context of climate change. And to kind of round off this conversation around field tests of solar geoengineering or solar climate engineering, I just thought I'd mention, in the spirit of kind of the interdisciplinary conversation that you're also interested in, this intervention that our group at the IASS published in 2013, when this kind of discussion around field experiments was really taking off, where we kind of raised some questions and remained somewhat skeptical of the need for these experiments at that moment in time. Right. So with that, I'll return to kind of the way that the story of solar geoengineering or geoengineering more broadly gets told by mentioning this very influential paper by Paul Crutzen. So these kind of developments that I've just outlined around field experiments also are generally seen within the context of a resurging interest in climate geoengineering that was kicked off by this contribution by Paul Crutzen, who had won the Nobel Prize for his work on ozone, who coined the term Anthropocene. So he's this very kind of visible, well-known climate scientist. And it's often suggested that before this intervention by Paul Crutzen, there was a taboo on researching and discussing climate geoengineering, so that it was not something that one would necessarily dedicate one's work to, or that one would bring up in conversations about climate change, kind of for various reasons, including fears that this would kind of draw attention away from, as I'd mentioned before, the moral hazard concern, would draw attention away from the immediate need to reduce emissions. And as we can see in this graph from a paper by Oldham et al. In 2014, indeed something seems to have happened around the time of the publication of Crutzen's intervention. So what this shows is the number of publications, of peer-reviewed publications per year on the total of climate geoengineering approaches in red, on solar radiation management by itself in green, on carbon dioxide removal in blue, and then there's this general kind of orange line. But what you see is that independent of kind of the individual, what these individual lines mean, there's this kind of this rapid increase around the year 2006. So something does seem to have happened after Crutzen allegedly broke the taboo on researching and discussing geoengineering, including what happened is that a series of assessment reports were published by various agencies. So the ones that I show here are from left to right, a kind of very influential assessment report by the Royal Society in 2009, influential also, since I believe this is the report that introduced the categorization of geoengineering technologies into technologies for carbon dioxide removal on the one hand and technologies for solar radiation management on the other. Then following that in 2011, a report commissioned by the German Federal Ministry of Research and Education, in which I was also involved as a co-author. Then a report commissioned by the European Commission and published in 2015, which came out of a project for which Mark Lawrence at ISS was the coordinator, and for which I then became the lead author of this final report. And in 2015, by the National Academies of Science in the US, who published 2 reports. So you can already see some of the changes that I've been gesturing towards in kind of differentiating out into different individual technologies rather than lumping everything together under the umbrella term geoengineering. So what they did is they published 2 reports, one on carbon dioxide removal and reliable sequestration, and one on reflecting sunlight to cool Earth, but both under this umbrella term climate intervention. So that's kind of how they solved this definitional quandary at the time. But these were by far not the first assessment reports to discuss aspects of climate geoengineering. So kind of getting back to this historical overview and this question of, well, when did research on this take shape and was there a taboo or not? We have reports mentioning and actually discussing in some detail climate geoengineering much earlier. So already as early as 1965, in this influential report, Restoring the Quality of Our Environment, by the President's Science Advisory Council at that point in time, advising President Johnson in the US. That report already included a short discussion of what we today call, and for what at that time there was no name for, I guess, but what we today call solar radiation management or solar geoengineering. And then kind of approaches for manipulating the global climate were also discussed in subsequent reports by US agencies. So the influential Changing Climate report and the Policy Implications of Greenhouse Warming reports, which are both reports that I'll get back to later in the talk in a different context. They also discussed aspects in some detail of what we today call climate geoengineering. And so I'd just like to draw your attention to this first oldest report, Restoring the Quality of Our Environment, and how the group back then that drafted this report thought of climate geoengineering. So this is it's the first report that really brought kind of what it's called, what is here called climatic changes that may be produced by the increased CO2 content to the attention of a very kind of like highest level politician, in this case US President Johnson. And what they say in the underlined portion here is that a change in the radiation balance in the opposite direction to that which might result from the increase of atmospheric CO2 could be produced by raising the albedo or reflectivity of the Earth. Such a change in albedo could be brought about, for example, by spreading very small reflecting particles over large oceanic areas. And this is interesting in many ways to me. On the one hand, because I mean, today we have small particles spread over large oceanic areas, and we call them microplastics, and we don't think it's a great situation to have them where they are. But that aside, I mean, at the point in time, this kind of was the one idea that came to people's mind for how to address this newly identified problem, which they say could be, at the very top, deleterious from the point of view of human beings. This was the kind of the very first solution that came to their mind, to this group's mind. Reducing CO2 emissions does not play a role in this report. So in a sense, today, many people would say that reducing emissions is plan A for dealing with climate change. And, if that proves to not be enough, then we might have to consider what is then called Plan B, climate geoengineering. But here at that time, this really was, in a sense, like the go-to solution. I mean, this was Plan A. So the idea was, well, we could potentially produce counteracting changes by manipulating the environment in certain ways. And so we have kind of like a sense now of the historical development of, should we say, modern discussions around climate geoengineering. And with solar radiation management in particular, I wanted to mention this one important contribution, which is actually the first proposal of reflecting sunlight by introducing reflective particles in to the stratosphere by Mikhail Budyko. So the first mention of the possibility to introduce reflective particles into the stratosphere came in 1974 in this book, which was first published in Russian and then in English as Climatic Changes in 1977. So in a sense, I guess what I want to bring forward from this historical perspective is that what we're seeing is that while one indicator of interest, the number of peer-reviewed articles that are published, as we saw in this graph that kind of rose steeply after 2006, that indicator seems to suggest that significant interest in climate geoengineering picked up after the publication of Crutzen's article. But this does not mean that there were no serious discussions of climate geoengineering before that, right? So we now have a history before us that stretches back to 1965 and that moves from the President's Science Advisory Council to this proposal for sunlight reflection via aerosol injection in 1974, and the introduction of the geoengineering term in 1977 by Cesare Marchetti. And that continued via various assessment reports by US agencies that I showed you. So the story that there was a taboo around climate geoengineering prior to 2006 kind of raises some interesting questions from an STS perspective and warrants some closer inspection. One might wonder if there were these kind of, relatively high level and fairly detailed in some cases discussions of climate geoengineering far prior to 2006, then what kind of work does this concept of a taboo around climate geoengineering prior to 2006 do for those who use it? And I've looked at this with a colleague of mine, historian Franz Maulshagen, who used to also be at the ISS, who is now at the University of Bielefeld. And this is from a forthcoming chapter in which we approach this question through a historical analysis that traces different phases in how kind of different imperial formations have imagined manipulating the climate over the course of a longer history. So we start actually very early on in our work. We show that the very moment in which the global climate became an object of modern scientific knowledge, which was in the late 18th century, it also became an object of imagined manipulation. And I'll get to those earlier phases in a moment. But for now, I'd like to draw your attention to this paper by William Kellogg and Stephen Schneider in Science in 1975, and to the various interventions that they imagined at the time might be implemented and that they show neatly on this map, right? And you'll see that already this map picks up the idea of creating stratospheric dust layer or one in space, as they say here on kind of the far right of this map. You see that inserted. So they picked up Budyko's idea very early, or might have perhaps heard it at conferences if they hadn't had access to an English translation of the book by then. So the point that Franz Maulshagen and I make in this paper is that many of the interventions imagined back then in the 1960s and 70s, as you can kind of see, as you can get a sense of this just from looking at what the proposals are on this map, many of these interventions are no longer considered really acceptable or feasible today by contemporary audiences. So for contemporary audiences, these are often too reminiscent of the kind of large-scale engineering projects of earlier times that came at tremendous human costs, or that from today's perspective are no longer considered acceptable for environmental reasons. Kind of these gigantic infrastructural projects, I mean, imagine like damming the Bering Strait or damming the Gulf Stream, creating artificial lakes in Northern Africa. That's actually something that kind of has a long colonial history. So, and it continues throughout the 1950s and 1960s. So it's actually a German engineer that at the time led a project that was investigating the possibility of creating artificial lakes in Northern Africa by exploding nuclear weapons there, kind of within this, thank God, short-lived enthusiasm for using nuclear weapons in kind of civil engineering projects to create things like artificial harbors or artificial lakes. So these interventions, like I said, are, to contemporary ears, they're not very palatable. We don't consider these good ideas anymore. And so in a sense, there is a taboo, or there was a taboo, there is a taboo on researching and discussing climate geoengineering kind of in these terms, right? Like involving these kind of outlandish, unacceptable proposals. So we argue that there was a need, the concept of the taboo speaks to this need. There was a need to create a boundary that allowed those interested in research on climate geoengineering to claim that their research topics fall on the right side of the boundary, right? So on the acceptable side, and have nothing to do with those earlier proposals that from the perspective of today have this outlandish quality to them. So this function, we argue, is fulfilled by the discursive figure of the taboo prior to Crutzen, which separates out what came before as kind of questionable, outdated, old, possibly outlandish, and then what comes after as state-of-the-art, contemporary, and morally unsuspicious. And if you compare this kind of map that you see here with a map that represents a geoengineering intervention today, this is what you see. So this is a map of what a climate engineering intervention is imagined as today. The red dots that you're seeing are injection locations. So all we see are the 4 injection locations where reflective aerosols would be injected into the stratosphere, right? So it kind of it removes all these kind of controversial and ambiguous seeming things, and just has these 4 dots that are kind of very, like not very, that don't look so outlandish, I guess, to audiences today. And what it allows for is a kind of envisioning of geoengineering as a design problem, as a problem of designing the climate in a way that it would be more suitable to humans than under a climate change scenario, because you can kind of time and organize the injections at these different locations in certain ways so as to optimize the effect that you're having on the global climate. So this is a very different kind of way of thinking about geoengineering, and we say in our paper that it speaks to a contemporary sensibility around ideas like flow and system and leverage that kind of are present in this proposal as it's put forward here. This proposal to see geoengineering as a design problem. And kind of expanding on this now, without having written about this in the paper, I was wondering in kind of putting together the presentation for today, whether that might not also be something like an explanatory approach that can inform us of the dynamic around these experiments that I've been discussing. So my sense is that this kind of boundary drawing between acceptable and possibly outlandish interventions can also help illuminate the situation around field tests of climate geoengineering. So the question is, so why is the Harvard University SCOPEX experiment, which is what it's called, stratospheric controlled perturbation experiment, on the top left here, that image, often referred to as the first solar geoengineering experiment, when there have been other experiments in the past? And my sense is that in the end, it might be useful for both sides, so for the proponents of the experiments and those who oppose them, to position this experiment as the first experiment. And so for the opponents, this does the work of kind of being able to present it as the first step down a slippery slope that needs to absolutely be avoided, kind of leaving out of the picture the fact that experiments have been conducted in the past and it hasn't really mattered to anyone very much, one might say. And for the proponents of this experiment, it can be presented as a model of how to do a proper experiment that has good experimental governance, which is what kind of the Harvard University group is really keen on emphasizing, that they're thinking hard about how experiments should be governed, kind of what kind of input should be sought from different disciplines, from different perspectives, different social groups. So by leaving out the prior experiments by Yuri Israel and by Lynn Russell, who was the principal investigator, the organizer of the E-Peace experiment that I mentioned, both sides can kind of focus attention on this experiment, make this experiment and their activities around it into the most urgent and important matters at hand. So it's, again, it's a kind of boundary drawing between the present and the past. And as I mentioned in our chapter, Franz Maulshagen and I go back quite far into the past, back to the late 18th century, which I'll only briefly touch upon here. We open with a quote by Johann Gottfried Herder, who says that now there is no question that as the climate is an embodiment of forces and influences to which the plant contributes as well as the beast, and which serves all living beings in a mutual relationship, man is ruler of earth also in that he may change it through art. So there's this idea that, you know, as soon as there was a concept available of global climate, that thing designated by the concept, global climate, also became the target of imagined manipulations. And kind of in that development, a very important step in the history of modern climate science was the comparative climatology of Alexander von Humboldt. This is a famous drawing, I guess, a graph by him, a map of isothermal lines, kind of heat distribution across the Earth. So you have, it's held in French and it's kind of difficult to read, but it, like on the left-hand side, or I guess in the West, if you like, you have America. In the middle, in the center, you have Europe, and then to the right or in the east, you have Asia, and it kind of shows this geographical space integrated via these isothermal lines. And what's been fascinating to me to learn is that Alexander von Humboldt himself, later in his life, in his kind of opus magnum Cosmos, which he really wrote decades later, himself reflected on the circumstance of how this global picture of the climate is connected to social and political processes of his time. So with the global climate, we get, paradoxically, or maybe also not paradoxically, a picture of global regularity and connection at the very same time, and even from the extremely violent expansion of Europeans into the rest of the world during the colonial period, an expansion that created vast differences among humans, at the same time gave us a picture of global natural unity, or we might say planetary natural unity. So this is a kind of dynamic that I'd like to spend the rest of my talk on, and I'll try and come to an end soon. I realize time is proceeding quickly. So I'd like to kind of dwell on this tension dynamic between, on the one hand, kind of very unequal developments in the social and political world that accompanied, or perhaps even emerged together with, this kind of unified picture of a planetary nature that we get in the figure of global climate. And so here are two contemporary pictures of planetary natural unity: the famous Keeling curve of rising atmospheric CO2 concentrations on the left, and the equally famous curve of rising global average temperature on the right. And so this is where I come to the third part of my talk, the final part, before I then get to the brief concluding remarks, in which I want to explore and question this picture of planetary natural unity, and complicate it a little by asking whose planetary natural unity we live in today, and what other visions of planetary environment got pushed aside along the way of getting to where we are now. So this also connects back now, as you'll realize, to my earlier mention of Paul Edwards' work around infrastructural globalism, right? So whose infrastructure is it that we inhabit today, that we are subjects of, we might say? So third part, Earth Systems Science and Global Climate Politics, starting off with a quote from George H.W. Bush, so the elder Bush, on the campaign trail in August 1988, looking to get elected to the presidential office of the US. He says, those who think we're powerless to do anything about the greenhouse effect are forgetting about the White House effect. And the reason I put this here is not because I want to say that George Bush was somehow committed to environmentalism or anything, not at all, but because it to me so powerfully illustrates how the global environment, the planetary environment, is also a space in which to project power, right? To say that the problems of the world can be solved from the White House. I mean, this is a supreme kind of assertion of global American power towards the very end of the Cold War, right? Which of course at the time was not anything that somebody provisioned. But what I've always wondered, I guess my interest in what I present to you now, and what I've always wondered is about the temporal coincidence of these developments. On the one hand, these incredibly tumultuous times of 1989, 91, 1989, 1990, 1991, on the one hand, and the consolidation of climate and climate change as a global problem in the form that we know it today, right? So in this very specific form in which it's kind of been institutionalized in the IPCC especially, which was founded in 1988 with support from the Bush government, and which published its first assessment report, I believe in 1992, if I'm not entirely mistaken now. So my sense as an STS scholar who is interested in the relationship between knowledge and power has always been that the incredibly uniform vision of global climate change that we have today has to somehow be connected to the emergence of the United States as the sole global power after the collapse of the Soviet Union. And yet, I found almost no traces of this in the published literature, but indeed, once one begins to look more closely, one finds, as one would expect as an STS scholar, that at the beginning of the IPCC stood a scientific controversy over what the right way is to know the planetary environment and the changes it is undergoing. And I'll start out by telling you this story of that controversy. So less than 2 weeks after the Berlin Wall had fallen, so in late November 1989, members of the then newly founded Intergovernmental Panel on Climate Change convened in Bath, UK, to decide how to predict the future of the planetary climate. One side held that future could be known empirically, from the standpoint of past climates, based on the records that ancient atmospheres have registered in soil, ice, trees, and corals. This was the so-called paleo-analog method, championed at the time by Soviet scientists of pioneering status within the field of physical climatology, and which I've already mentioned to you in this talk today. So chiefly Yuri Israel, who was the chair of Working Group 2 of the IPCC, and his colleague Mikhail Budyko, who was a member of that working group. The two had published many things together and were very high standing in the climate scientific community. So Professor Anisimov, who I saw on your program, gave a talk towards the end of last year, writes in a paper in 2020 that conversations with German meteorologist Hermann Flohn prompted Budyko's idea of using warm eras in the geological past of the Earth as possible analogs for studying the climate in the future. Soon he charged his colleagues and students with undertaking this task. Within a short time, they developed and substantiated the paleo-analog method, which for many years remained the main tool for constructing climate forecasts in the Soviet Union and Russia. So this is, however, an approach that found no favor with a younger group that represented a different vision for scientific and political order at the planetary scale. So if the paleoclimatologists were the empiricists of global climate, then these were the theoreticians of global climate, hailing from the North Atlantic, and organized around computer models built upon principles that were themselves beyond historical time, so explicitly not empirical. Empiricists of global climate, the theoreticians made it clear at Bath, would not be among those authorized to predict the future of a changing climate. And this was more than technical, for it meant defining what specifically the abstract normative subject of global politics was subject of. So in internal communications, this is now tracing work that is quoted in Scodvin 2000. In internal communications, kind of members of the IPCC expressed their concerns around the paleoanalog method. One of them saying in a lead author of Working Group 2, saying in an internal communication to colleagues in Working Group 1, if this material is included in Working Group 2's report, there are serious implications for policy, especially for the do-nothing strategy. And I should say that Working Group 1 is on the science of climate change, and Working Group 2 is on the impacts of climate change. So these are kind of the two working groups. Working Group 1 was headed at the time by John Houghton, a strong proponent of kind of the theoretical approach of Earth system modeling, and Working Group 2 was headed by Yuri Israel. So John Houghton then wrote to Yuri Israel and said in his letter, it will be of no use to policymakers if we offered them two quite distinct predictions without guidance on which we believed was most credible, because the sense was that the two methods, the paleoanalog method and the computer modeling method, would produce very different visions of what future changing climate holds for humans and how politics should be organized in response to that. And so this is kind of the background against which that meeting in Bath was called. And Houghton's invitation letter to the Bath meeting again emphasized that, quote, this is not just an academic issue. The forecasts from the two techniques are different and may have different policy implications. And so it is important that the issue is resolved amongst those who are best equipped to deal with it. And if we then fast forward now from the Bath meeting to the publication of the IPCC report, which in fact was published in 1990, I now see on my own slide, not in 1992, like I said before. So this is a quoting now from the Working Group 1 report by John Houghton and colleagues, saying, in conclusion, the paleoanalog approach is unable to give reliable estimates of the equilibrium climatic effect of increases in greenhouse gases. And reflecting on this episode in a book that he published in 2007, the chair of the IPCC, the overall chair of the IPCC, Bert Bolin, a Swede, this book is kind of a personal memoir / history of climate politics. He recalled that unease grew also in the course of the work by Working Group 2 because of the lack of balance in the choice of lead authors of the different chapters in the report. Several scientists from the USSR led the assessment process, and scientific as well as practical difficulties arose. This was finally resolved when one of the co-chairmen of the working group, M. Teagart, Australia, together with some of his Australian colleagues, took on the task of compiling and editing the final report. So in the end, Yuri Israel, the chair of Working Group 2, was not the author of the Working Group 2 report. This, I think, is quite significant. I'm not sure if it's been the case for other working group reports within the IPCC. The working group chair is not also the first author of the resulting report, but it shows how the extent to which kind of climate modeling, the theoretical approach to the prediction of climate change, how substantially it succeeded in this historical situation. So, as STS scholars, we might ask, where did this controversy originate and what exactly did the two sides in the controversy represent? How is it that computer modeling of global climate became an effective marker for separating out those authorized to speak on behalf of a global community, united by its shared existence on a changing planet, from those not authorized to do so? And even, how did the United States end up on one side of that division and the Soviet Union on the other? Because of course it is not the case that the Soviet Union at the time was not, did not have advanced computing capabilities. Of course it did. So why did kind of computer modeling of global climate become in a sense, American approach here? And I think to understand this, we have to go back to earlier in the 1980s, when when the U.S. began efforts to build a research program around first the idea of what they called habitability of planet Earth, but that didn't really take off. What did stick in the end was the idea of global change, and especially, and this is what I focus on here, the idea of the Earth as a system and the attendant research agenda of Earth system science. So Earth system science was and is built in particular around the use of satellites on the one hand and Earth system computer models on the other. So these are kind of reports coming out of US agencies, NASA and the National Research Council, that establish kind of this idea of the Earth as a system and Earth system science as the way of knowing that system via Earth system models and remote sensing and satellites. And these efforts fed into international efforts, especially the International Geosphere Biosphere Program, right? So this was an international effort, but it was in important ways shaped kind of by the work and the concepts coming out of the US at the time. And from there, it also moved into the IPCC. So this is the kind of the genealogy of Earth system science that I trace. And I follow a recent piece by Julia Rispoli and Dubravka Olsakova, which have recently interpreted the emergence of the IGBP, the International Geosphere Biosphere Program, in the context of rising Cold War tensions between the US and the Soviet Union. So they say the IGBP evolved in a divisive situation where US-Soviet scientific collaboration coupled with political antagonism. And what they mean here are things like a Soviet invasion of Afghanistan and the Strategic Defense Initiative by Ronald Reagan, so-called Star Wars program. And they continue, these circumstances made US scientists more eager to find ways to use the IGBP as a diplomacy device to counter the Soviet ascendancy in MAB specifically, in the UNESCO natural sciences sector more generally. And what they refer to here is a sense, a perception that Soviet scientists were particularly influential in UNESCO, and within UNESCO, especially in MAB, which is the Man in the Biosphere program, right? So this is an interpretation in which US scientists sought to establish a US-dominated counterweight to what was perceived as a Soviet Union-dominated UNESCO, and specifically UNESCO's Man in the Biosphere program. And they have this interesting, fascinating piece of evidence that they present, where the CIA, in a recently released note, kind of gives like an interpretation of what will happen if the US withdraws from UNESCO, as it then did in, I believe, 1984. And in particular, with regard to science, they say, the Soviet and East Bloc delegations to UNESCO recently have successfully lobbied a key French science official in the Secretariat to include the theme of ecological consequences of the arms race on the agenda of the program on Man and the Biosphere. This is an example of how Soviets have politicized otherwise respected programs in this sector. According to Soviet Ambassador Yermolenko, UNESCO cannot avoid reflecting political and ideological trends. We can expect the science sector, which the US Embassy reports has been reasonably free of political bias, to become more politicized given the success of this Soviet initiative. We believe the UNESCO science sector could well become a participant in current international discussions on the climatic effects of nuclear war and nuclear winter research. In that event, the Soviet media will be able to cite UNESCO as an expression of international interest in this subject. We have not seen any evidence that US allies would work vigorously to oppose these Soviet uses of UNESCO science programs. So in this interpretation, fearing a Soviet scientific campaign against nuclear weapons just at the point when America was winning the nuclear arms race, US government agencies supported the institutionalization of a counterforum for setting the agenda on planetary environmental matters. And that forum was Earth System Science and the institutions associated with and influenced by it. So far, so good, but this is kind of where that paper ends. This is kind of the historical situation they leave us with. kind of in the mid to late 80s. But I'm interested in taking this a step further and asking what precisely the institutionalization of Earth system science and its associated techniques of knowledge production meant within the co-production of knowledge and power of natural and social order. And here it's very instructive to compare two statements from influential reports that I already mentioned earlier in this talk, the reports, in the context of climate geoengineering. So the first quote reads, viewed in terms of energy, global pollution, and worldwide environmental damage, the CO2 problem appears intractable. Viewed as a problem of changes in local environmental factors, rainfall, river flow, sea level, the myriad of individual incremental problems take their place among the other stresses to which nations and individuals adapt. It is important to be flexible both in definition of the issue, which is really more climate change than CO2, and in maintaining a variety of alternative options for response. So this is in 1983 in the Changing Climate report that I had on the earlier slide. And it's a quite remarkable commitment to flexibility, to taking alternatives into account, to thinking about more things than just CO2, right? It's really more climate change than CO2. But that seems entirely forgotten in this second quote from the 1992 report that I had on the slide, Policy Implications of Greenhouse Warming, which reads, greenhouse warming is global. Neither the location of release nor the activity resulting in a release makes much difference. A molecule of CO2 from a cooking fire in Yellowstone or India is subject to the same laws of chemistry and physics in the atmosphere as a molecule from the exhaust pipe of a high-performance auto in Indiana or Europe. Although the results of climate change will differ from place to place, they derive from global processes. So what happened in the intervening time period between 1983 and 1992 is the institutionalization of Earth system science, and with it, two developments. First, the strong focus on the carbon dioxide molecule as the cause of climate change, and second, the globalization of climate change such that it can only be conceived of as a global matter today. And both of these developments, I argue, are closely related to the success of Earth system science and Earth system modeling. And Sheila Jasanoff and I, in our collaborative work, we refer to this framework that is encapsulated in the bottom quote from 1992, this framework of thinking about the planetary environment as the single carbon framework. And that framework has been contested from pretty much the start. So already in 1991, in a report coming out of India, the Center for Science and Environment, Anil Agarwal and Sunita Narayan asked the rhetorical question, can we really equate the carbon dioxide contributions of gas-guzzling automobiles in Europe and North America, or for that matter, anywhere in the third world, with the methane emissions of drought cattle and rice fields of subsistence farmers in West Bengal or Thailand? Do these people not have a right to live? But no effort has been made in WRI's report to separate out the survival emissions of the poor from the luxury emissions of the rich. So WRI is the World Resources Institute, to whose report they are responding with this report. Just what kind of politics or morality is this, which masquerades in the name of one-worldism and high-minded internationalism? So it's a critique of kind of the unifying, or the presentism and the unifying tendencies of focusing on only the physical properties of carbon dioxide and leaving out kind of the normative valence attached to the carbon dioxide molecule, right? So who emits it, for what activity, for what purpose, right? Subsistence farming or an American SUV, so these kinds of normative questions fall by the wayside if one thinks only in terms of physical properties of CO2 molecules. And interestingly, I've found a quote from Kirill Kondratyev, who's an outspoken critic of the IPCC, but an internationally recognized scientist, for example, in the WMO, the World Meteorological Organization. in which he seems to also criticize the single carbon framework. So he says, in the case of the global carbon cycle, everybody is worried about the increase of carbon dioxide in the atmosphere, and a catastrophic scenario is feared. So this is in 1998 in an interview he did with the WMO Bulletin. Yet we know that the actual increase is not as much as the calculations show. The main reason for this is that the biosphere assimilates a great deal of carbon dioxide emitted in the atmosphere and guarantees future ecological safety. And this is what I find so interesting about the quote now. If we destroy the biosphere, which functions as a sink for carbon, we create an ecological catastrophe. Studying carbon dioxide or ozone in isolation will serve little purpose. Such studies should be made in the context of the overall problem. And that is, of course, exactly what is at stake here. What is this overall problem, right? Is the overall problem global average temperature and the concentration of carbon dioxide in the atmosphere? Or is it, the systematic destruction of the biosphere? Is it the very kind of unequal geographies of human development that have come with the widespread use of fossil fuels? Kind of all these different interpretations of what the problem is of a changing environment, of course, then lead to different interpretations of what the politics around that problem should be. And what we have here now is precisely the co-production, of course, of social and natural order that I've been trying to get to in this talk. So I will cut this a bit short now. I have a series of kind of constitutional moments in climate politics from 1988, the founding of the IPCC via the adoption of the UNFCCC and the adoption of the Kyoto Protocol in 1997, the failure of Copenhagen in 2009, and the adoption of the Paris Agreement in 2015. The point that I want to make with this kind of time series is that what I see as having emerged in opposition to each other here by the early 1990s is, on the one hand, the single carbon framework of climate science and politics, and on the other hand, resistance to an interpretation of that framework in which emissions are only assessed based on their material physical properties, while issues beyond CO2, as well as normative dimensions of CO2 emissions, such as equity considerations based on past emissions or moral concerns around luxury versus subsistence emissions, are left aside. So we can then interpret the history of global climate politics via these opposing positions, and they're reflected, for example, in the 1992 principle of common but differentiated responsibilities in the United Nations Framework Convention on Climate Change, and by the fear in 1997 that kind of the uneven market that the Kyoto Protocol creates, because it doesn't include all countries, but it only includes some countries that have kind of caps, like Kyoto prescribed ceilings that they need to stay below with their emissions, but others don't. The fear that this will kind of create carbon leakage. Like all this kind of comes from the opposition between, on the one hand, the single carbon view, and then on the other hand, the desire to differentiate between kind of different moral and normative positions. And in a sense, that is that Gordian knot is cut in a sense only in 2015 with the adoption of the Paris Agreement, which on the one hand says it will limit, as I said in the beginning, temperature rise to well below 2 degrees Celsius and pursue efforts to limit the increase to 1.5 degrees Celsius. But on the other hand, knows no annex countries. So that means it doesn't differentiate between developed and developing countries, and instead asks for only voluntary, so-called nationally determined contributions. Now, I have a series of quotes from US presidents starting in 1997 with Clinton. And I'm gonna put them all up here. I'm not gonna read them all, but the point is that Clinton via Bush, via Trump, via Biden, they in a sense all say the same thing. They always say, well, whatever we do, other countries emit so much CO2. Yes, we may emit 20% or 15% of global emissions, but that also means the rest of the world emits 80% or 85%. So it's always this balancing of kind of present time emissions saying that, well, yes, the US will lead, but others must follow. And there is no differentiation based on, for example, past emissions or based on the normative status of carbon emissions. So I'll give you some very brief concluding thoughts, which basically consist of this single slide, because what I show you here is the cover of a book that came out in 1990, in which the relationship between different approaches to climate science are envisioned differently. So this is an alternative model for thinking about how kind of the empiricism and the theory of the theorists of global climate can think together. So this is the result of a collaborative research project under the 1972 US Agreement on Cooperation in the Field of Environmental Protection, which brought together scientists from both sides of the Iron Curtain to assess, quote, the influence of environmental changes on climate. So under Working Group 8 of the agreement, chaired collaboratively by Michael Buduko and Alan Hecht of the US Environmental Protection Agency, this group, which also included Mike McCracken and Yuri Israel, published this concluding volume in 1990 titled Prospects for Future Climate, a special US-USSR report on climate change. And the opening page informs the reader that, quote, what has evolved from these joint efforts is an innovative approach to projecting future climate change based on the hypothesis that we can combine the strengths of what we have learned about past warm periods and what we can simulate with our models. So they call this a two-pronged approach, which emphasizes equal-footed collaboration and thus markedly differs, I would say, from the IPCC's insistence, or at least Working Group 1's insistence, that paleoclimatology at best could serve as a kind of support to a dominant approach of Earth system modeling. So the question that I put to you is whether perhaps a collaborative approach in science instead of a confrontational approach, as we saw it in the IPCC, might have brought with it too a different kind of politics, possibly that one that allows for a broader imagination than what Sheila Jasanoff and I call the single carbon. And with that, I'd like to thank you all very much for your attention, and I do look forward to the conversation.
Thank you very much, Stefan, for a very insightful talk. So before we proceed to the Q&A, let me just briefly announce the rules of the house, so to speak. So first of all, I'll be abusing my position as a moderator and ask the first question, and then I'd encourage people to speak, or if you have to go, or for any other reason, just leave the question in the chat. So the procedure will be as follows: you can either raise your hand, as Sergei Astafov is doing right now in the chat, not in the chat, in the list of the participants. You can see that, or you can post in the public chat that you want to speak, or you can just write me a personal message. All right, so that's going to be the rules. And as I said, I'm gonna use my position as a moderator. So again, thanks very much for the talk, and particularly for this slide with Cesare Marchetti. Because I think historians among us will understand it's a very particular, exquisite pleasure to find some obscure paper that marks, some important shift, which especially, people who are Foucauldian by orientation will understand. So I was wondering if you could talk a little more about the origins of maybe of this paper, or just about the fact, which I think is very significant, that sort of the geoengineering seems to originate in some sense in this very particular institutional site, which is the Institute of Applied Systems Analysis, which is indeed one of the very important institutions of the late Cold War. And some people doing history of policy sciences, for instance, would argue that this institute and also the general field of policy sciences, which it represented and represents still, was functioned as a medium of communication between the two sides divided by the Iron Curtain, and so that the kind of technocratic, policy science field had its own politics. And basically, that there's a book by Egle Rindzevičiūtė, The Power of Systems, who argues that this institute was in fact, the medium of exchange between, the Soviet Union and the West, and that within this kind of cybernetically minded policy science culture, people were actually developing politically liberal ideas. So to maybe put it in a slightly more simplified form, from what you said about the IPCC, it seems that climate science was, at least at some point, the field in which some kind of geopolitical battle was taking place. This controversy between paleo climatology and modeling. But if we look at the history of policy sciences more generally, and especially at the Institute of Applied System Analysis, which also, it seems from your talk, is significant for the geoengineering story, it's somehow the opposite, right? So policy sciences serve as a medium of communication rather than controversy. And all this is just to ask you to talk a bit more about this Cold War story. Thanks. Oh, sorry. Yeah, I need to enable. Yeah.
Okay. Yeah. Sorry, I wasn't able to unmute myself. So yeah, the Cold War story. It's a you build from a small question to a very big question, Dimitri. Thanks for that. I'll say that I guess I'm maybe less interested in the specific political content of ideas, such as are policy sciences somehow inherently liberal or not, and more in the kind of the ways in which, in specific historical situation, knowledge and power are organized together in kind of an active mode of co-production, right? So there's this other way of, or one way of thinking about co-production is to use it as a tool for analysis, but another way is to think about it as a strategic activity that actors actually pursue in the real world, right? So to organize knowledge and power together is something that is can be a strategic effort, and that is what I'm interested in here. And that also means, in interesting ways, I mean, an implication of that is that such efforts can succeed or fail, right? So co-production, there can be more or less successful co-productions of natural and social order. I've always been, this is something I'm trying to grapple with, so it's really interesting that you ask whether, this kind of single carbon framework should be considered a successful or an unsuccessful co-production of natural and social order. Because on the one hand, it's become, so ubiquitous. It's been kind of structuring, or together with this kind of oppositional dynamic between resistance to that idea, it's been structuring climate science and politics for like a couple of decades now, right? But on the other hand, I mean, I think the lack of progress on matters of climate change shows that it's perhaps not the most successful way to organize nature and society together, right? So that's kind of the dynamic that I'm interested in, this historical situation, which has its origins in the late Cold War, where there is kind of an active, there's this moment of, in which, there's like an organized, like opposition is organized to a perceived threat or a perceived dominance of Soviet scientists and existing institutions. And from that organized opposition arises what we today know as Earth system science, and which kind of structures much of how we think about our world, including concepts like Anthropocene or planetary boundaries that came out of the Earth system sciences more recently, right? So it's kind of that dynamic that I'm interested in more perhaps than the kind of, is it a collaborative or an antagonistic approach? Because even if it was organized, in opposition to something, that doesn't mean that it can't have international appeal. Earth system science has very much international appeal. And it fed into the IGBP, right? The International Geosphere Biosphere Program, which was an international program, and it led to collaborations between scientists from all different kinds of places. So, of course, it's collaborative in that sense, and there is, it does foster cooperation and perhaps, mutual understanding on that level, and integration, and everything that kind of the rhetoric or the ideological self-description of science would say, international science is about, right? It's about kind of building those connections and having those kinds of conversations across political differences in the politically neutral language of science, right? But at the same time, it is, of course, also a knowledge power formation, to stick with the Foucauldian terminology, that, produces a certain kind of order. And that's kind of that's what I'm interested in. Does that respond to most of some of your question, at least?
Thanks. Sergei Astahov.
Thank you. Can you hear me? Okay, nice. Thank you for a very informative and inspiring presentation. I have lots of questions, but I will keep them short. Just three short questions. The first one is, as far as I know, there's an international ban on geoengineering measures at the moment. So do you think that this ban might be lifted at some point? And do you know about any developments in this direction? That's the first one. Do you want me to continue to give them all, or just? Okay, the second one is geoengineering is defined via large-scale interventions, but there are also small-scale and mid-scale interventions. And do you think that they can be somehow regarded as geoengineering? Or is it some kind of gray area from the lawmaking point of view or some other points of view? And the third one is, in your opinion, is the ethnography of IPCC possible? Because as far as we know, they don't allow non-members on meetings, on their meetings, to participate. 3 questions. So 2 about geoengineering, and the last one is about IPCC. Thank you.
Yes, thank you very much for those excellent questions. The international ban on geoengineering, yes, there's at the Convention on Biological Diversity, might be what you're referring to, there's a decision that has kind of evolved over the years that is often referred to as a moratorium on geoengineering. So that's absolutely correct, yes. And I do think that, I mean, one thing I didn't go into in my talk at all is the kind of actual political context today of geoengineering, and also some of the really kind of problematic issues that it raises. One thing that that you might have, like the map that I showed with the 4 injection points had no political boundaries, like there's no countries there, right? But of course, in the end, it will be a country or a group of countries that decides it's time for us to manipulate the global climate. And then after that, you'll still have extreme weather events, except that now you'll also have a solar geoengineering intervention. And so those extreme weather events are suddenly blameworthy. What was before a force majeure is now possibly the result of a geoengineering intervention. It becomes a source of conflict, right? So there's all kinds of really difficult and problematic international political aspects to this that I didn't go into. And therefore, yes, I think the political developments at the CBD are one aspect of that, where there is the attempt to respond to kind of difficult political and ecological questions that geoengineering raises. And that actually, I mean, it kind of feeds into your second question about geoengineering as, on the one hand, defined as this very large scale activity, but on the other hand, also smaller scale activities possibly being categorized as geoengineering or not. And I think what that points to, well, on the one hand, kind of the terminology that we've started using at the IESS is for kind of large scale manipulation of the global climate. We say climate geoengineering to specify it in that way. And for kind of a broader set of environmental manipulations, we might then say broadly just geoengineering. But on the other hand, I mean, geoengineering is, of course, also, it's not just a descriptive category, it's also an actor's category that can be used in political struggle, right? So it's quite, like, I mean, two examples maybe that I've written about elsewhere. There's a map online by a German foundation and a Canadian NGO that identify, I think, hundreds of kind of ongoing geoengineering projects, right? And what they, of course, do by using that kind of language is drawing attention to these projects as highly problematic and worthy of international attention, right? So they say these are things that people need to care about. This is geoengineering, and it is of questionable normative status. Right, so that's like kind of the scandalizing strategy, to scandalize certain things by saying they're geoengineering. And then the other extreme, perhaps, is from a paper a scientific paper or a commentary paper, I believe, that kind of, I think it's actually a response to what I showed, what we published in 2013 from our group, our commentary on field tests. In a response to that commentary, I think the authors say, well, but what if we paint our driveway white and measure the change in reflectivity? Would that be a geoengineering experiment? Should we not be allowed to do it? Like, should that be regulated under international law? And obviously what they're doing by using it that way is they're trying to, you know, kind of do the opposite thing of what the NGO and the German foundation are trying to do. They're trying to kind of say, well, it doesn't make sense to categorize these things as geoengineering in the first place, because like there should not be that kind of attention, or it's not problematic if I paint my driveway white and then measure the change in reflectivity, right? So they normalize. The one is a strategy of scandalization, and the other is a strategy of normalization. So it's, I'd say actually it's mostly interesting to me, geoengineering as an actor's category, not as an analyst category. And then is ethnography of the IPCC possible? I know it's extremely difficult, but I think there's actually an ongoing project doing exactly that. And so they got permission. It's a group that got permission to do that kind of ethnographic work and interview the IPCC members, the authors and lead authors, and kind of sit in on the meetings and conduct ethnographic work there.
And who they are?
So I'll be happy to be in touch separately, perhaps, and give more information.
Okay.
Yeah.
Thank you so much.
All right. So we also have Ольга Бычкова with us, but Ольга, вы готовы задать вопрос? All right. So I'm entitled to speak on her behalf because she's probably gone. And we have a few questions, and I'll start with the first one. So, which is probably the most expansive. So, in the history of geoengineering, there are certain waves of interest to the topic. You know, papers are published, projects get funded, there are public reports, and so on. And then for 10 years, there's nothing. So there's a kind of cyclicality to the field. You know, in terms of the scientific and public attention it gets. Well, do you think that's the case? And if so, what would be your explanation for why you know, it goes in cycles? So there are also a few others. Do you want me to read them all, or? Okay. So the second question is, if you know other work, meaning natural science work on geoengineering, perhaps experiments beyond Boudica and Israel, just, you know, if would be eager to hear about that, if you can share anything. And so the third question is, you partly touched upon that, is basically what excites you about the topic as a social scientist, as an STS scholar. And the fourth question, which is also related to that, how do you, I mean, what's your perspective on the kind of purpose of social studies, of geoengineering and climate change more broadly, given that many of the social and ethical controversies that emerge around geoengineering, climate engineering, have already been written about by Crutzen and Keith and other people in physics and natural science. So 4 questions from Olga Bычkova, who is sadly no longer with us, but she was here, through your talk, through the entire talk.
Absolutely, thank you so much. Those are difficult questions, all of them, and I think they might go. Well, I guess the one I can answer quickest is the one about experiments beyond Buduko and Israel's experiment. So I mentioned the EPEACE experiment, the Eastern Pacific Emitted Aerosol Cloud Experiment, I think is what it's called, what the acronym stands for, which was run by Lynn Russell in, I believe, 2011, and which kind of looked into marine cloud brightening technology. There's been plans for more marine cloud brightening approaches, experimentation, field experiments, also on the West Coast of the US, I think run out of mostly the University of Seattle, the University of Washington in Seattle. But I don't think those experiments have proceeded, at least not to my knowledge. There have been these ocean iron fertilization experiments in the 1990s. Those, as I mentioned, became controversial, or at least one of them became controversial. And so there's been a kind of hiatus since, but now there's again interest picking up. And as I mentioned, we're involved in a project on that as well with our group. And then of course the Scopex experiment, right? The planned experiment out of Harvard University by David Keith and Frank Koich and colleagues, the stratospheric controlled perturbation experiment, which was supposed to fly out of Sweden, I believe this summer, maybe next month even, but it was canceled over opposition from local groups. So those are the experiments I'm aware of that I would kind of categorize in a more narrow sense than this, than the group that I mentioned that has this map with all these hundreds of ongoing experiments or activities. In a more narrow sense, those are the experiments that I'd categorize as geoengineering. And certainly, yes, the history of geoengineering follows waves, and there's a cyclicality to geoengineering research and scientific and public attention. And is this currently, like, are we in a high phase now, and will we be declining again, and will it be forgotten about? I mean, we as social scientists are of course hesitant to make predictions, but my prediction here is that this will not so soon go away. I think such momentum has built around the situation that I described in the beginning of my talk with the Paris Agreement and the temperature targets there, that when kind of the situation comes where it is very, very difficult or no longer at all plausibly possible to say we'll achieve these targets, then pressure will, I believe, grow from many quarters. I'm not sure entirely from where specifically, but like whether, the Fridays for Future movement will then say, well, now we need to do geoengineering, I don't know. But I think certainly some scientists, possibly also, some from industry and politics as well, will find this as a kind of platform on which to advocate for a way to manage the climate crisis, right? So I think public attention, yes, comes and goes, but I think for now it's here to stay with this topic. What excites me as a scholar? Well, I think to me, it's exactly this kind of longer historical perspective that I find so interesting. Like how this idea kind of developed over time and morphed, changed in ways, right? So it didn't stay the same. Like you can kind of follow these different cycles again here, or phases in which climate manipulation, what we today call climate geoengineering, is envisioned very differently in these different historical contexts and within different knowledge power formations, right? So one thing that Franz Maulshagen and I do in our chapter that I mentioned is we kind of look back at these very early days of imagining the global climate as an object of modern scientific research, and at the same time imagining how that object might be manipulated. And the way in which people think it might be manipulated at the time is by cutting down all the trees in North America, like happened in Europe, because that's how some, at least, I mean, this is a debated topic, and Franz is more of the expert than I am on this as a historian. But at the time, there was a controversy around why it is so much colder in Quebec in Canada than in Paris, when the two are essentially on the same longitude. And so the idea was, well, it's because kind of Europeans have put so much work into Europe, right? Like cutting down the trees, building civilization. And if that were done to North America too, then the North American climate would warm, right? So it's kind of this agricultural vision, like an agricultural society that envisions the manipulation of their climate via this agricultural technology of tree cutting, right? And then moving on, of course, moving into then the late 19th century, one sees a situation in which the technologies of the day are no longer agricultural, but they're industrial, right? So you have things like gigantic dams and gigantic canals and artificial lakes. And this is like when, the Suez Canal was built. So these kind of giant engineering projects all of a sudden become imaginable to people. And it's especially kind of the water bodies of the world that people imagine manipulating, right? So there's this kind of vision coming out of this obscure European German context for Atlantropa, right? For kind of like connecting Africa and Europe by draining the Mediterranean, right? Like all these kind of crazy ideas for manipulating water bodies through engineering technology. So like I'm fascinated by how different societies in different historical contexts imagine how nature and society fit together, and how kind of the idea of manipulating climate takes shape in those different contexts. And then of course thinking about how we think of that today. And that brings me exactly to the fourth question: what is the purpose of social studies of climate change and geoengineering? Well, it's to open up this kind of historical perspective and thereby open up a possibility space that's not visible from within kind of the entrenched imagination that comes out of, that sits within kind of the boundaries that contemporary visions of natural and social order come with, right? So I think, to me, I mean, this is the purpose of kind of interpretive, critical, social scientific work, is to ask about how what we take for granted today is, has its historical origins, has its blind spots, and to ask how we might envision the world differently, right? So what other orders are possible, right? So if we say co-production is an active process of bringing together visions of natural and social order, then how else might we envision natural and social order together, right? If not via the single carbon framework that we described. So opening up kind of alternative imaginaries of possible futures and worlds, that to me is the important task that the kind of interpretive and critical social sciences, and STS especially, bring to scholarship in academia and the public. I mean, this is now coming to the what you mentioned at the very beginning of the talk, how to engage with a broader public. This to me is exactly the way to do this. On the one hand, it's to kind of ask about the imaginations out there, because oftentimes there are imaginations out there that we do not account for in the halls of academia, if we and especially not within science, right? So this is like the idea of transdisciplinarity, for example, to connect to perspectives from outside of academia and to bring those to bear on how we imagine the world and possible alternatives to it. And then on the other hand, feeding that back into the public. So one way in which we do that is by regularly organizing kind of a large event that brings together all these different constituencies for open discussions. This is what we call the Climate Engineering Conference Series, or now we've actually changed the name with this year's iteration, which will take place in October. Now it's been postponed from last year because of the pandemic. We've changed the name to Climate Engineering in Context, because we want to emphasize precisely this kind of need to contextualize discussions that otherwise occur only within a very narrow framework.
Thanks very much. So for those who are listening silently, I'm prepared to take questions. But I also have a few questions from, left by people who had to leave. So I'm gonna make it 2 instead of 4. So the first question is actually related to what you just said, and that's from Irina Antashuk, who is our colleague, who is also very interested in geoengineering. So she asks, how do you see the relationship between social and natural sciences studying geoengineering? Where do they meet, perhaps intersect? Are there any ruptures, contradictions, tensions? So how do you see, this perspective of interdisciplinary collaboration, given that, often it happens that, we, the STS crowd, just go to study them rather than, do something meaningful together. So that's, I think that would be the question about, how is interdisciplinary work possible in this field?
Yeah, I mean, I have no like 3 bullet points to follow, and there you go. But I mean, for me, it has had aspects of all of what you mentioned. I mean, of course, there are situations in which it's really difficult to have conversations across disciplinary boundaries, or I would say STS is an interdiscipline, so it has these kind of possible connection points to other disciplines. But it's still difficult to make those connections, and it requires open-mindedness on both sides and the willingness to look for common ground and shared understandings. I think, to me, when you said do we just go study them, I think certainly not. I mean, at least in the work that I do in the kind of co-productionist branch of STS, the point is exactly not to kind of just look in at science and look at how they produce knowledge and how they iron out uncertainty or whatever, right? But kind of look at what scientific knowledge does in the world, like how does knowledge leave the laboratory, right? So it's not just studies of what happens in the laboratory, but what happens after knowledge passes from the laboratory into society. And that, I think, that is something that scientists are extremely interested in too. Again, they like that to me has always been like the point where the connections are most interesting and most fruitful, kind of thinking about what it means to place something like the global average temperature or the global concentration of CO2 in the atmosphere at the center of our climate politics. Like, and then most scientists would say things like, no, it's about much more. Of course, it's not just about that. Maybe it's a good proxy for certain things, but we also have to care about other things. And those are, the meaningful conversations I think to have. And then, there's a general openness often I find to kind of think about, because many scientists do care about how their work works and and what value it has for different publics. And so thinking about that together, I think, is a fruitful way into collaborations as well.
Yeah, thanks very much. There are also, there's another question from Irina, and also a question from Vasily Pigunidis, who is our friend and colleague in economic sociology. So I'm gonna, because they're related, I'm gonna ask them as if it's one question. Do you think there is a stabilized public or scientific discourse on geoengineering, and what kinds of tropes it draws on? What kind of imaginary representations are circulating? From those which are circulating, which ones are sort of the most stable? If you think that's this kind of question could be, makes sense. And so, for instance, there is this idea of the Parliament of Things, the Latourian idea that, and I'm gonna just read Vasily's comment for those who are gonna be watching us at some time. So the concept is, a concept according to which animals, things, places must be included in the governance of our common world, and that they should be represented, and that those who are going to represent them usually are experts, scientists, engineers. And so the question is whether you think that, what is your sort of take on this idea in the context of geoengineering? And also Vasily wrote that he sees a parallel here with the opposition stated in the 19th century by the followers of Saint Simon, between the government of men, seen as something of the past, and the government of things, which is supposed to replace it. Without debates on climate change, we see the re-emergence of a certain technocratic vision, a vision that implies the substitution of political conflict for a discussion between representatives of various issues at stake. What is your analysis of this situation? Do you think that there is a room for political leeway? So first question is about imaginary representations, and second one is about Parliament of Things. I tried to make them one, but obviously I failed. All right.
Yeah, thanks. One thing that I think, reflecting on my own talk now a bit, that came out in my talk is that there's probably not a stabilized version of the story of geoengineering, or maybe to some extent among some groups, but I don't think that there is a stabilized idea of this is geoengineering, this is what it is, this is what it does, this is what we should do about it in a broader public. For one, because that term, like I said, is itself so contested, right? So it would depend a bit. I think what is stabilizing at the moment and normalizing with it is this idea of carbon dioxide removal or negative emission technologies. That is coming mainstream like 100%, right? That is now firmly ingrained in how most people probably think about, who think about these things, how most people who think about these things think about how the Paris targets can be achieved, right? That there's a need to develop these carbon dioxide removal and negative emissions technologies and remove carbon from the atmosphere. I mean, that's what climate neutral and net zero, these concepts, these slogans are all about, right? I mean, the idea of neutrality is precisely that you have a balance between, as it's called in the UNFCCC, the United Nations Framework Convention on Climate Change, between sources and sinks, right? I mean, the concept is there already that you do not, that at some point you do no longer emit more than is removed from the atmosphere. And then you can say, well, but maybe back in 1992 they meant only natural processes, like CO2 was taken up from forests, and they didn't, weren't talking about bioenergy with carbon capture and storage, or direct air capture of CO2 or whatever. But that idea kind of was there, and now it's it's really, that is stabilizing, I'd say. Like that is like net zero, climate neutral. That points to a stabilization of what was before kind of the carbon dioxide removal category of geoengineering, and which now probably most people would say no longer should be seen as geoengineering. But that also, like the other side of that equation is, of course, that geoengineering itself is not stabilized, because that thing, that chunk of it, like that second subsection of geoengineering, has just been removed from that concept, right? So perhaps then, geoengineering is stabilizing as solar geoengineering, like, and that now the dominant imagination of geoengineering is reflecting sunlight away from Earth. But then what about the marine-based approaches, right? I mean, those are tricky to conceptualize, because they're kind of, I guess they're seen at least as this intervention into like an uncontrollable mass, like the ocean waters, right? Which has like food chains and complicated things, like a complicated ecology. So in that sense, it's not contained, like removing CO2 from the atmosphere at one point and storing it elsewhere. Although, of course, the extent to which that is contained itself can also be questioned, perhaps not necessarily physically, but economically. Like, what happens if you create new markets for these things? Like, how does that disturb existing relationships? And I think there's a lot in flux. Some things might be stabilizing, but we'll continue to see a lot of changes in this area. I think how people think and talk about these things. That's, of course, fascinating for us to study as social scientists. Then the second question was about the parliament of things. Yes, is the parliament of things a depoliticization, like a technocratic vision of representation rather than of antagonistic kind of Chantal Mouffian politics? I mean, I think the pendulum of, of course, the material world matters, and that was an important contribution that actor network theory made, is to kind of introduce the material world back into social theorizing in a sophisticated, highly sophisticated, and extremely productive way. But at the same time, I think that pendulum of, of going from like, there's nothing outside of text, to going, everything is now an actor, right? Every material thing is now also an actant. That pendulum has swung too far in that direction of everything is an actant now, and every material bit matters. So I guess that's my response to that question. I think probably I'd be sympathetic to that interpretation that was given here of the Parliament of Things.
Thanks very much. So unless there are any questions, which I don't see any hands raised in the chat, I think we can wrap it up here. And I'd like to again thank you, Stefan, for being with us and for a very insightful talk, and also for spending more than 1 hour answering questions, which is highly appreciated, I'm sure. Thanks very much, and I'm gonna stop the recording now.